Hello friends, you're welcome. Today my topic is differentiation. So differentiation is a important topic of class 12th. It is a beginning of calculus. Calculus is having a major portion in class 12. In class 11 there was a little introduction of differentiation, but in class 12 you have a calculus, because first of all you have to understand differentiation, then only you can do all the type of differentiation, then you can do application of derivative, and because integration is the inverse of the differentiation, so then you must have a knowledge. It means the whole calculus, the 50% part of your syllabus is depending upon these portion. So here we have formula. So you have to learn all this formula of differentiation. So we are starting from any algebraic function. Suppose we have x to the power n, then the differentiation of x to the power n will be nx n minus n. For example, suppose you have to find differentiation of x to the power 5. So using this formula, you will have to write 5 x to the power 5 minus 1, 4. You will apply this formula. Now we have to learn that sin x differentiation is cos x, and the differentiation of cos x is minus sin x. The differentiation of tan x sec square x. So these are the formula you have to learn, these trigonometric all formula. Now come first algebraic function, then trigonometric. These are called exponential function. It means there is a real number and the power is a variable x, a to the power x. So the differentiation of a to the power x is a to the power x log a, and in this case the base of the log is e. Now differentiation of e to power x, e is called Euler constant. It is also type of exponential, and the differentiation of e to power x is e to power x. Simple. Now the differentiation of log ax, but a is any real number different from e. So in case of a, the differential coefficient is this, but whenever the base is e, so differentiation of log x is simple 1 upon x. Now come to the inverse trigonometric function. The differentiation of sin inverse x is 1 upon under root 1 minus x square, and the differentiation of cos inverse x is just minus of this. This is the strategy to remember. Now differentiation of tan inverse and cot inverse, sec inverse and cosec inverse x. Now you will have to use this formula. This is called product rule. Whenever you are differentiating a product of two functions, so the formula is first function as it is, then differentiation of second, then second as it is, differentiation of first. And you can generalize this formula. Suppose you have three functions. So first differentiation of f1 remain these two as it is. Now differentiation of these two, second function, now these two as it is. Now the differentiation of third function and these two as it is. So we can generalize this formula. Now quotient formula, the differentiation of u upon v. So denominator, we have to take denominator first, the differentiation of u, that is numerator, then minus u as it is, differentiation of v, and upon v square, that is denominator square. Now in running way, most of the question we will use shortcut method, that is the differentiation of under root x will be 1 upon 2 under root x, and it can be proved. Suppose we have to find differentiation of under root x, which means x to the power 1 by 2. So using this formula, n x to the power n minus 1. So we can write x half minus 1 is minus half, and we know that if x is negative, so we can make it positive by putting it into the denominator. Now under x to the power half can be written as. So directly we will remember this thing, that the differentiation of under root x is 1 upon 2 under root x. Is a very useful formula. Now differentiation of 1 upon x, in the same manner we can prove it, but we will use it directly, that the differentiation of 1 upon x is minus 1 upon x square. Similarly, suppose instead of sin x there is a sin 5x. It means 5 multiple of x. So what will you do? Suppose the differentiation of sin x is cos x. So similarly, the differentiation of cos ax is cos ax but in multiplication you have to put a. So I am giving you an example. Suppose you are differentiating sine 3x. So sine 3x differentiation cos 3x with this formula, but because with x there is a constant 3, so you have to multiply it. So this is, you have to remember. Another example of this, you know the differentiation of e to the power x is e to the power x, but because with x there is a constant k, so you have to multiply with this constant. So this formula you have to remember. Now I am going to tell you what do you mean by chain rule. Keep watching. So what is the chain rule to differentiate? Now see this question, we have sin x cube, and in this question we have sin cube x, and it is sin 3x. So I have put these question, I have taken these two questions, so make it clear. Now, so you have, what is chain rule? Suppose this is not x cube, suppose this is x, suppose this question is x. So you know what is the differentiation of sin x? Yes, the differentiation of sin x is cos x, but x is this. Now what do you mean by chain rule? The differentiation of sin x cube is cos x cube. Now you have to differentiate what you assumed as x. You have to differentiate this function. Because this was not x, it was x cube, so you have to differentiate. So cos x cube into the differentiation of x cube is 3x squared. So this is the answer. Now come to this question. We can write like this, sin x whole cube. So now we are going to differentiate it. Suppose this function is like x. So you have x cube. So what is the differentiation of x cube is 3x squared. So you will write 3x squared. So whom you suppose x? So you have to differentiate this function also, sin x. So 3 sin square x, and differentiation of sin x is cos x. Similarly, now your differentiation is not x, suppose it is x. So the differentiation of sin x is cos x. So you have to write cos x first, then the differentiation of 3x is 3. So this is called chain rule. So I am taking more question to make it clear. Keep watching. So to understand chain rule, we have 4 more questions. So first of all, we have to differentiate this function. So suppose it is x, though it is not x, it is under root x. Suppose it is x. So what was the differentiation of e to the power x? E to the power x. But because you have supposed this question as x, so you have to differentiate this function. And remember my shortcut key for under root x. You know the differentiation is 1 upon 2 under root x. So here we have the answer. Now similarly, we have to differentiate e to the power tan x. Now suppose it is x. Make it simple. So e to the power x differentiation is e to the power x. So which we suppose x? So differentiate of this tan x. So differentiation of tan x is sec square x. So done. Now we have to differentiate this function log sec x plus tan x. Whenever something is not written, it means the base is e. Okay. So suppose this function is x. So your function is become simpler, log x. So what is the differentiation of log x? 1 upon x. But don't write x. X is this. Sec x plus tan x. Now differentiation of which you suppose as x. So now the simplification. Differentiation of sec x is sec x tan x, and the differentiation of tan x is sec square x. So from numerator you can take sec x as common, you will left with sec x plus tan x, and sec x plus tan x, cancel it, so you got sec x. Now come to this question, you have to differentiate log x plus x square plus 1. So treat it like x. So what will be the differentiation of log x? It will be 1 upon x. So put it, but obviously it is not x. So you have to differentiate of this again. So 1 plus x under root x square plus 1. Now come to this bracket. Differentiation of x is 1. Now further you have a function. Suppose inside under root there is x. So it will be under root x. And what is the differentiation of under root x? 1 upon 2 under root x. Now again applying chain rule. Because you suppose this function as x to make it simpler, so you have to differentiate this also. X square plus 1. So 1 upon x plus under root x square plus 1. So 1 plus 1 upon 2 under root x square plus 1. Now the differentiation of x square is 2x, and obviously the differentiation of 1 is 0. You can cancel 2 with 2. So 1 upon x plus x square plus 1. Now take LCM. X square plus 1 plus x upon under root x square plus 1. This can be cancelled. So you will left with 1 upon under root x square plus 1. This is your answer. So in next video, I will tell you how to differentiate implicit function, then how to differentiate parametric function, then how to differentiate using logarithm. So keep watching. Thank you very much.